Okay, guys, what we're going to do is our kind of day one of AP review. I know we actually got finished taking an exciting 2-day test. That was really our beginning, but I wanted to go over a couple of things. First of all, the syllabus, hopefully you got a copy of it on Tuesday. I had that out. I had a big note on the board. Please know that the first AP homework is due Thursday evening, and so I'm just saying it again in case you missed the note or you missed the syllabus. I also posted the syllabus on Moodle so you have access to it. We really only have 3 homework assignments for this 6 weeks, and if you miss one, that would be bad, right? We just have 3. That's all I got. I have 1 for this week, 1 for next week, and 1 for the week after, and then we really won't have homework assignments later unless I decide to add one. I'm not deciding to add one at this time, but I could later, I suppose. But right now we have 3 homework assignments. And so just wanted to give you an update about that. All right. The paper that I just passed out to you about the exam structure, you've just gone through the exam structure, but I do want to talk to you about the whole exam. So it's split into Section 1 and Section 2. The Section 1 is worth half the points, 50%. Section 2 is worth 50%. The very first thing is basically the multiple choice. You're going to do the multiple choice first. You have 28 questions to do in 55 minutes. You'll do the non-calculator first, just like we did on Tuesday. Then you're going to switch to calculator. You have 17 questions to do in 50 minutes. They give you more time on the calculator section. I'm just guessing because of calculator, like actually physically putting stuff in your calculator. Typically, students will have trouble finishing Part A, the non-calc, but usually they will be able to finish Part B, the calculator part. They usually, for whatever reason, some students have a difficult time finishing the non-calc, but are okay finishing the calc. Once you do the multiple choice, then you go into the free response, and on the free response, you're basically going from calculator to calculator. You would have your calculator with the multiple choice that you just finished. You're going to hold on to the calculator, and you're going to do 2 calculator problems that are going to take a total of 30 minutes, so they're going to give you 30 minutes. Then after that, you will do 4, these are our free response problems. You'll do 4 free response problems that are non-calculator, and that you will have 60 minutes to do those. So that's the structure of the test. Let's talk about allowable uses, or basically what they have designed for you to do with the calculator on the exam. There are 4 things that they are going to test you on that you basically need to know. You need to know how to graph a function in a particular window. They love giving you functions that are difficult, like really small or really big, so you have to mess with the window. So just know that you may have to adjust the window several times. You are expected to be able to find the zeros of the function with the calculator, which we all know how to do these things. You will be expected to numerically calculate the derivative and the integral. So those are the 4 things that they want you to be able to do with your calculator. If you do anything else with the calculator, it wouldn't be supported. Like if you wanted to find a max and min on your calculator, you would have to show additional work, the proper work, to be able to use that. You wouldn't be able to just use that, if that makes sense. They don't. That's not an okay thing. Mm-hmm. Sure. Yeah. You can use you can graph the derivative. You can use the numeric values from your graph for the derivative. All of that is fine. You can do all those types of things. They just don't like regressions or max min finders. That is not part of the test, and that you would not be able to use those features and get any points for that. So that's an overview of what the calculator is, the allowable uses of the calculator. So I've had several students ask, well, if I do well, how many multiple choice questions do I need to get, a 5 and that kind of thing? So what I did is I have found a calculator, a BC calculator, like little applet online, that you can play with that. If you want to write this URL on your blue sheet and that's something that's interesting to you, like how many multiple choice questions do I need to get right to get a 5, or what's the format. There are a total of 45 multiple choice questions, and you would just adjust the little counter It's appass.com, calculators, calculus BC. And there's the 6 free response questions right here. They actually have done a little bit of a strange thing on this number 5. They've split, so each question is worth 9 points. We know there are 6 and they're all worth 9 points. But they've done a bit of a strange thing here. They've split question number 5 into A, B, and B, C. That is really not how the actual test is scored. I'm really not sure why they did that. They're actually, on the test itself, there are 3 free response problems that you have and AB students have. You have identical, 3 of yours are identical to 3 of AB students. You'll have 3 AB free response problems, and you will have 3 BC free response problems. Now, of course, the BC free response problems can have AB material on it. It's just 3 of them are also on the AB test. So if you have a friend that's in AB, you'll have 3 of the same free response problems. Does that make sense? And on this little template, for some reason they took 1 and they split it to A, B, B, C. I don't really know why. But at any rate, this template, actually the rubric changes every single year. It's not going to be the same rubric. You know, like at 1 year to get a 5, you may need 68 points. And the next year you might need 72. And the next year you might need, 66 or something. I mean, it alters year to year. So out of 108 is the total. So it changes. It changes from year to year. We just don't know. But at least this, if you're one of those that really wants to know, what do I need to do, this will give you a little bit of be able to play with it. Yes. Right. It's like 1.2 points or something. This is worth 50% and this is worth 50%. So whatever that makes, they're exactly the same. So that's just something that I wanted to bring to your attention in case, because I've been asked that several times, and here's where you could play with it if you would like. The next thing that I want to do is actually go through a free response problem together. This is number 1 from the 2014 test, from last year's test, and I would like to go through it with you and talk to you about the different calculator techniques. I'm going to walk you through with the calculator technique that I would suggest. If you have other techniques, please feel free to use them, but I just would like to help you be quicker in your calculations. So let me give you a copy of this free response and then we'll work through it. Okay, so this problem was the first problem that my students last year encountered. It is on the exciting topic of grass clippings. Yes, so we have grass clippings are placed in a bin where they decompose. For the time 0 to 30, the amount of grass clippings remaining in the bin is modeled by this function a of t. So the very first thing when we see the function, we need to note exactly what it is. Is this a derivative? Is this a position? And this is the amount of grass clippings, so this is a position. So we just need to know that. So this is a position, where a of t is measured in pounds and t is measured in days. All right. Once I see that I'm given this type of equation, I kind of scan the parts A, B, C, D, and see if this equation is going to be used over and over again. And it actually is. You'll notice that I need it in part A and part B and probably other places. So what I would do, the very first thing that I would do then is I would go to my calculator and I'm going to type that equation in, my y1, and I'm going to type it in only one time. I'm only going to have to type it in once. So I need to be sure that I type it in exactly correctly. Since you're only going to do it one time, be sure it's perfect, because if you type it in wrong, you're going to get wrong answers for everything and you'll lose points. So type it in. So I have it in y1, 6.687 times 0.93, what was that, 931 to the t. And in our case, in the calculator, it would be to the x. So type that in your y1 for me. Okay. So now what we're going to do is look at part A. So part A says, find the average rate of change, A of t, over the interval 0 to 30. Indicate units of measure. All right. So we want an average rate, and we have a position. So we have to decide which of the two formulas we're going to use. We want an average rate, and we have the position. Are we going to use slope of the secant, or are we going to use the average value formula? We're going to use slope of the secant because we have the position and we want the average rate. Okay, so we're going to use slope of the secant. And so here's what you would need to write on your paper. This is all you need to write. So we want slope of the secant here, and wherever they're going to give you space to do work. For me, I'm just going to write it up here. So this is part A. We would need to do A of 30 minus A of 0 over 30 minus 0, and then write an answer. There, you don't have to write the function out just to save time. It's already been named A, so you can just use the name. All right, so we write that out. So now let's go to our calculator, and I'll show you a fairly quick way to take care of that. So we go to a clear screen, and I'm going to type in, so I need to get to my y1, and if you have the new operating system, you can hit alpha F4, and the y1 is right there. If you don't have the new operating system, you'd have to go into vars, yvars, and pick up the y1. So I'm going to do y1 of 30 minus, I'm going to put my y1 of, was it 0? 0. And I'm going to go ahead and get that number. So that's the answer for the numerator. Then I'm going to divide by 30 minus 1. I just do that in my head, right? I'm just going to divide by 30. So I'm going to divide by 30. And that gives me the answer to part A. So part A, we would write that equals negative 0.196 or 0.197, whichever way you want to go, whether you want to truncate or round. And our units would be pounds per day. All right, so we would write that equals negative 0.196 or 197, whichever way you're going, pounds per day. And that's all I would need to have written on my paper for part A. Okay? Let's look at part B. Part B says find the value of A prime of 15 and using correct units interpret the meaning. All right, so part B. Let's go back to our calculator. And I want to find A prime of 15. So again, in a clear screen, I'm going my derivative. So that was math 8. So I would put an x in here. And right there, I'm going to pull down my y1 again. So alpha F4 y1. I want the derivative of y1 at, what was it, 15? Yeah, at 15. And put in my 15, and then hit enter, and there's my derivative value. Okay, so my derivative value is negative 0.1635. You can say 0.163 or 0.164, whichever way you want to go. So let's write that out. So A prime of 15 equals negative 0.163. Yep. So I'm writing the exact work that you'd need to show. A prime of 15 equals negative 0.163. And then the explanation. That needs to be fairly specific. I'm going to write the explanation down here with B. So we really do not want to talk about slopes of derivatives or graphs. We want to be very specific to the problem. We do not have to write a paragraph here. We're looking at a sentence. And the sentence would be, one possible sentence would be, on day 15, the amount of grass clippings in the bin was decreasing at 0.164 or 0.163, depending on which way you rounded or truncated, pounds per day. That's all you need. And you could, so let's say you wanted to show the rate as being negative, then instead of saying decreasing, you could just say the rate. You know, the rate was, and then write the negative. But you don't want to do both. You don't want to say decreasing and write a negative. Yeah, because you could say on day 15, the amount of grass clippings in the bin was changing at a rate of 0.164 pounds per day. You can say it like that. Yes? Uh-huh. So good question. If you write the units in your description, you do not have to write the units up here. But it has to be in the description. It has to be one of the other places. You don't have to write them both places. I would write them in the description because that's what they're giving you the point for, is the description. So that's where I would put them. All right. All right, is that okay on part B? All right, let's go to part C. Part C says, find the time T for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval. Wow. So we're thinking of that. It's like, what in the world are they talking about? So we need to pull it apart into pieces. All right. Find the time T for which the amount of grass clippings. Got to stop there. That's the equation. Right? The equation. The equation in the bin is equal. So the equation equals the average amount of grass. Now we did an average rate up here, and we used slope of the secant, right? Because we had the position. If we want an average amount of grass clippings, we're going to have to do the integral one, right? That's what we're going to have to do. So what we want to do is we want to write that out. So this is the work that you need to show on part C. You need to say A of t equals, you do not have to write the equation out again, just name it, its name. A of t equals 1 over 30 integral 0 to 30 A of t dt. Okay, that's the work that you need to show. You don't need to show any other work than that. Now we're going to do some work on our calculator, but you don't need to show it. That's what you need to show. This is what you're doing. You're setting the function equal to the average value of the function. Okay? So there's a couple of ways to do this on your calculator. One of them takes quite a long time to graph, and the other one is a bit quicker. So I do want to talk to you about both techniques. All right, so let's pull the calculator back up. All right, so let's look at our two options. We know we need to set the equation itself equal to something. And I have the equation in my y equals, so it's there already. I could choose to put the integral statement in y2. And I could do that, and I could intersect them. The calculator takes an extraordinarily long time to do that, because it's having to calculate the the integral constantly as it graphs. So if I was actually going to graph the integral, I would need to put it in here, right? If I was going to graph the integral, like if this were, 0 to x or something, and it was just a function, I would need to put it in y equals. But it actually would be faster if you calculated this number on a plain screen, on the blank screen, and then stored it and put it right here. So let's do that. Let's go to a blank screen, and let's calculate this number right here, this 1. So it's 1 divided by 30. And then the integral, math 9. So we're going from 0 to 30. And we're using y1, so I'm going to pull that down. So alpha f4 y1 of x. So that's going to give me a number. Okay, I'm going to take that number. I'm going to store it as alpha a. Okay, and just to check that it's in there, okay, it's in there. So now what I'm going to do is I'm going to go into my y equals, and I'm going to intersect my function with alpha a, with this integral right here. So I'm doing what they're asking me to do. I'm intersecting. My window, let's change it to like 20, something like that. And let's graph. So it's graphing my original function, and now it's graphing that integral value. If we put the integral in as y2, this line right here would populate very slowly. And you would need to go on to something else and then come back to that, because it's going, I swear, it takes like 30 seconds to a minute to do that if you put the integral inside of y2. So this one was faster, so we're going to intersect. So we would do secant calc, intersect, and we're going to go over there to the intersection and hit enter, enter, and enter. Okay, so that's our answer, 12.414 or 12.415. So let's go back over here and let's finish. So time equals 12.414 days. And that's all the work that you need to show on part C. Okay? For part C, it doesn't ask us, it just asks us to find the time when the average amount is equal to the average. So it doesn't ask us to interpret on part C, so we don't have to justify there. It isn't asking for a justification, though we know if it doesn't ask for justification, that doesn't mean anything, but in this case, it just wants a number. All right, part D. For t is greater than 30, L of t, the linear approximation to A at t equals 30, is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time at which there will be a half pound of grass clippings remaining in the bin. Show the work that leads to your answer. Now, here, show the work that leads to your answer is talking about, we're going to need to do that. So, linear approximation, that word brings confusion and fear to some students. I hope that we are not in that boat, but we've talked about it several times before. I'm going to remind you, linear approximation just means tangent line approximation. That's all it is. You find the tangent line, you stick the number in. That's it. Right? We just need the tangent line at 30. That's what we need. So let's write the tangent line at 30. Let's write it in abstract. So part D. The tangent line is going to be y minus, and we're at 30, so y minus a of 30 equals a prime of 30 times t minus 30. Okay, that's my tangent line approximation. That's my linear approximation vehicle. That is showing work right there. It says show the work that leads to your answer. Okay, here's my work right here. Okay, so I don't have to type the equation, write the equation in because it's already been named. We have to be very careful and name it what they name it. If you call it f of 30, they're not going to give you any points. That is how particular they are. You really have to call it exactly what they name it. All right, so this is my tangent line approximation. And so what I want to do, it says at which there will be a half a pound of grass clippings remaining in the bin. So I'm going to show, this is my generic equation. I need to show the half being plugged in. And then that's really all the physical work that I need to show. The rest I can do on my calculator. So we know that y is a half. So we'd say 0.5 minus a of 30 equals a prime of 30 times t minus 30. Okay, so that's the writing work that we need to show. Now once we've shown that, we're going to go to our calculator and we're going to take care of this. We're going to calculate that. Is everybody okay so far? All right, so let's go to our calculator and calculate this. Okay. So let's see, what do we need? We need a of 30 and a prime of 30. We need those two numbers. So I'm going to go to my blank screen and I'm going to get those two numbers. So a of 30 I'm going to get by pulling my y1 down. I'm going to do y1 of 30. And that's going to give me a of 30. And I'm going to store it as b. And I'm going to write over here, I'm going to write b over here, which I can't write right now, but I would write b over here to know where I put that. So this is going to be a of 30 is in b. Now I need a prime. So I need math 8. I've got to do the derivative. I have to do the derivative of my y prime. Pull the y prime, y1 down again. And I want my derivative at 30. Okay, so that number I'm going to store as c. So we store it as c. Okay, so I have these numbers in my calculator, this one as b and this one as c. So let's start working it. So I'm going to do 0.5 minus that number I stored as b. Okay, I'm going to get that. Then I'm going to divide by, see this piece right here, I'm going to divide by my derivative value, which was at c. So I'm going to divide that by c. That gives me that value. And then what's left to do? I have to add 30 to it. Then I'm going to add 30 to it. And that's my tangent line approximation, 35.054. Okay, so we would go back over here and write that in. So our t value equals 35.054 days. You need to be sure to write the units. So we check back. So we predicted the time, we showed the work, we have completed what we needed to do on part D. Okay, how is that?